Hello ladies and gentlemen, this is Mr. Green and this is another in my Algebra 2 lessons. And just to let you know where we're at, we're starting Unit 8. This is the last unit in this semester, so you need to be careful. Make certain you've got everything caught up, all the zeros taken care of. You don't want to be caught with having zeros in your grade book, so you want to make certain you're getting them all caught up. This is really the culmination of where we've been leading to this entire semester. We've been talking about solving all sorts of different issues, but it's all been leading up to quadratics. And that's where we're at right now. You're going to be looking at graphing quadratics. You're going to find the axis of symmetry, some coordinates of the vertex of the quadratic function, and draw and graph quadratic functions in a standard or a factored format. So you need to make certain you understand how these work, okay? So if we're looking at the standard form of a quadratic equation, quadratic equations have this x squared term in them. It'd be ax squared plus bx plus c. That is the standard form of the quadratic equation, okay? Now, a obviously can't be 0 or it's not quadratic any longer. A has to be some number. If it's a positive number, then a values the quadratic is going to be pointing up like this. If it's a negative number, then your quadratic is going to be pointing down like this. I like to call it the hook'em horns and the rainbows. Okay? So if your a value is a positive a value, it's going to be a hook'em horns. And if you stick values of x into this equation and come out with y values, you will see that it forms this little hook'em horns type shape like this. Okay? And if it has a negative value here, like this one does over here, and you stick x values in and solve it for y's, you'll get this little rainbow looking value. Those points could be plotted, and then you would see what your little parabola would look like. By the way, quadratics always produce a parabola. It's not a line any longer, it's a parabola. Okay? Parabola means that type of a curved shape that you're looking at. Okay. So let's look at what's going to happen. To find the axis of symmetry, we use this formula right here. What is that formula? That is the x value for the vertex. It is this line that runs through the parabola right down here. That is the place where you can fold it in half and it matches up on either side. How do we find it? We take the standard form of the equation. We take b minus negative b divided by 2a, and that will tell you the x value of the axis of symmetry. That's simply that red line. To find the actual vertex of the axis of symmetry, this point way down here, you have to take that x value, stick it back into the equation, and solve it for the y value, for the f of x. Okay? So let's see here. Here we've got this right here. If I take this, my x value for axis of symmetry, I just abbreviated axis of symmetry, will be equal to negative times negative 12. Where'd the negative 12 come from? Right here. That's my b value, negative 12, divided by 2 times 3. Well, this is going to give me an x equals 6. So, not having coordinates on here, let's see if we can't put a coordinate graph on here. Let's see here. Let's do that. And we will get a nice solid black line coming down like this, and that'll be my y-axis. And we'll get a nice solid black line going across like this, and that will be my x-axis. Okay? And then we'll change this to that. So this is my y, and this is my x. Okay? So x equals 6. 1, 2, 3, 4, 5, 6. This will be my AOS. AOS meaning axis of symmetry. No, wait a second here. Negative 12 divided by 6 is 2. Okay? My axis of symmetry is way over here. Boy, was I half asleep on that one. Okay? Thanks for pointing that out. Get rid of that. I don't want that there. That would have confused everyone. Okay, there's my axis of symmetry. Okay, seeing that I've got a positive 3 here, that tells me it's going to point up, so that's why I drew it in the direction that or where I've got the coordinates as I see right now. So now x equals 2. I'm going to stick that in. My y value is going to be equal to 3 times 4, 2 squared, minus 12 times 2 plus 6. That's 12 minus 24 plus 6. That's equal to a negative 6. So if I go to 2, negative 6, 1, 2, 3, 4, 5, negative 6, move you out of the way. Thank you. Negative 6 would be right about there. I can tell you what my parabola looks like now. It looks something like that. It's going to go up like that. Okay? If I want to stick 1 in here, because that's one of the values that I can see that it's going to go through, 3 times 1 is 3, minus 12 plus 6. That's 9 minus 12. That's going to be equal to a negative 3. Well, guess what? 1, 2, 3. There's negative 3 right there. That means that's another point on my graph. Okay? And that means there would be one right there, too. And I could draw my graph going through those points. I'm not very good at drawing these things freehand. Okay? And if I stick 0 in here, well, 0, 0 plus 6. That means it's going to be all the way up at 6. 2, 3, 4, 5, 6. That's going to be way up here. Okay, that means way over here. And if I go from here to way up there, it's going to go through that point. I didn't get there. Didn't do a very good job of getting there. Okay? Doesn't have these bows in it. Shouldn't have those bows in it. But then again, I'm not real good at drawing these type of graphs. Okay. So, can you do it in other ways? Sure. Let's look at this. This is just my calculator. If I key this in, 3x squared minus 12x plus 6, and I hit enter, and then I graph it, what do I get? I should get a parabola that looks like that. Much better job of drawing that parabola. By the way, the line in there is something completely different. That was a y equals x line. Yep, there it is right there. There it is. Now it won't be there. And if I zoom 0, which is not what I wanted to do, zoom 6, standard zoom, it'll show it to you a little bit better, and that's what it looks like. Cool? So you can see we can graph these out that way, and I just graphed it the hard way here on paper. Okay. So how do we determine how many times it crosses the x-axis? These are called the 0 points here, or the roots. How do we determine those zeros? How many there are? Well, if the graph is above the x-axis, obviously there's no real solutions. If it crosses the x-axis at one point and only one point, then there's one real solution. If it crosses at 2, there's 2 real solutions. 2 real zeros. 2 points in which y will equal 0. Okay? So this is not that difficult to determine. If I'm looking at an equation like this, I can try and factor it. Okay? If I'm factoring this, it's going to be 3 times 3 and x plus 3 and x plus 3. See how these are the same values? Since they're the same values, that tells me that my axis of symmetry is probably going to be x equals 3, or x equals 3. Let's try that. My axis of symmetry is negative 6, divided by 2 times a, which is 2, which is equal to a negative 3. That doesn't make any sense. Okay? And my roots here are going to be at x equals negative 3 as well. That means negative 3. That means that this one has one and only one solution. There's my x, there's my y. If I go to negative 3 here, my parabola is going to look like that. Just one solution. Touches the x-axis in one and only one location. This one, however, I would look at it and say, I can tell already I'm not going to have my AOS is going to be negative b, which is 0. Well, there is no axis of symmetry there, is there? Well, yes, there is. There's the x-axis, or the y-axis. It'll be right along the y-axis. Won't change any. But if I try to factor this and find the roots for it, I'll discover that it has no real solutions. It does something like that. Nothing real. So if I stick 1 in here, 1 squared plus 2 is 3. So at 1, it's at 3. It should have gone through that point right there. At 0, it would have gone through 2. So you can see it goes like that. I did a very good job of graphing here. Can you see what I'm talking about? That would be the graph of it. No real solutions. Nothing that would have touched the x-axis. Okay. So, how do we determine the number of zeros? We look at those roots. The number of roots, if the roots and the axis of symmetry are the same, then what you're talking about is one solution. I want you to notice if you take the roots, halfway in between the roots is the axis of symmetry. So if I'm halfway between them and it's the same number, obviously it's the same. So what are we talking about here? We're talking about how to find 3 points that you would normally use to graph a equation. If you're giving a quadratic equation in standard form, you factor it to find these r values, the roots, and you use the axis of symmetry to find the vertex. You find the vertex, you find the roots, and that tells you 3 points that you can use to graph the quadratic equation. Okay? So let's try a couple of them here. So let's start off with, I'm going to try to factor this. Well, I can see that 3 times 1 and x is going to be the other value that I'm using there. If it's going to be an x minus 3 and an x plus 1. Why? Because that's going to give me a negative 3 and a negative 2. That's going to be my factored answer. That's going to give me roots at x equals negative 1 and x equals 3. So there's going to be a root right here and a root right here. That means those two places where it crosses the x-axis. Adding those together, I can see that I'm going to get a 2. And so my axis of symmetry is going to be right here on that line, number 1. Okay? Added them together. 3 minus 1 gives me a 2. Divided by 2 gives me a 1, halfway in between them. So there's my axis of symmetry. Positive, it's going to point up, right? So if I know my axis of symmetry is at 1, I stick a 1 in here and I get 1 minus 2 minus 3. That's minus 5. That's minus 4. So it's going to be down here at negative 4. And I now have 3 points, and I can see what the quadratic equation is going to look like. It's going to look like that. And I'm not very steady at drawing, but that's what my quadratic equation looks like. Cool? Okay, let's do another one. Here's a little bit more complex one. I'm going to actually divide by negative 0.04. Negative 0.4. Divide by negative 0.4. Why am I dividing by negative 0.4? Well, that makes this go to 1, negative 0.4 times x squared minus x plus or minus 12. That's what 4.8 divided by negative 0.4 is a negative 12. Well, when I factor this, I'm going to get x's. I'm going to get a 3 and a 4, and it's going to be a negative 4 and a positive 3. That's what it's going to be. So I'm going to have negative 0.4 times this times that. Well, this tells me I've got a root at 4 and a root at negative 3. Okay? My axis of symmetry is going to be negative of a negative. That's a positive 1 divided by 2. It's going to be right here at 1/2. Okay? If I take 1/2 squared, I get 1/4 plus 1/2. That's or minus 1/2 would be a negative 1/4. Minus 12 is going to be a negative 12. That's going to be way down here somewhere. So my parabola is going to look like that. And my wavy lines are not what I intend there. I just cannot hold a steady hand to draw that. Okay? Oh, wait a second. I see a problem with that already. I didn't multiply times the point 4. If you don't multiply times that 0.4, it'll give you the wrong answer every time anyway. My axis of symmetry is still at 1/2. Okay? So, it looks like it's going to be, let's see here, try this again. I get 1/4, oh no, that's not squared, that's squared up there. So I get, if 1/2 is my axis of symmetry, I get 1/4 minus 1/2 minus 12 all times negative 0.4. Well, that's going to be a negative 1/4 minus 12. That's a negative 12 and 1/4. And those are going to cancel each other out. And that's going to divide in there, what, 3 times? Yep, 3 something. It's going to be down here at 3 something. And so what are we looking at? We're looking at a fairly wide hook'em horns like this. One of the things I hope you're seeing is the smaller absolute value that I've got here. Oh, Charles. Did you make that mistake on purpose? Yes, I guess you did. Because you wouldn't have made it normally. I'm sorry. It's a positive 3. So it's going to be up here somewhere. All right? Come on, pen, work with me. Up here somewhere. So my graph is going to do that. So it's a little bit of a wide rainbow. Now, why? See how I got a positive 3 down here? 3 something? That's where it came from. Okay? I have a negative number here at the beginning. That tells me it would point down. I should have caught that to begin with. But that's what my axis of symmetry is, still at 1/2. And I found that point, graphed it. Okay? So, one more here. It says find the y-intercepts for each of the quadratic functions. Y-intercepts. This is just so simple. Okay? I want you to think about this. Y-intercepts is when x is equal to 0. 0 plus 0 minus 8 equals negative 8. My y-intercept is negative 8. It's right there. That is the y-intercept, negative 8. That's how you can go about finding these values. Easy. It gives you another value you can plot. So let's go back here and look at this one. 4.8. It should have crossed right up here somewhere. Should have crossed the x-axis somewhere up there. I must not have divided right. It must be a little bit higher up here for my vertex. Don't know. I'd have to go back and do my division on my calculator. I really didn't want to do that, but I guess I'm going to have to. Okay, on 12 clear. Quit. 12.25 divided by negative -zero point 0.4. And that gives me a 30. Ooh, that was way off there at 3. That's why my value is way off. 30. It'd be way up here. So my graph would be up this direction more. Okay. I've really messed this one up very, very badly. But I hope you realize what I did and how I worked it. Okay? So, if you have questions, even after I've messed this up, bumbled through it a little bit, feel free to give me a call. Come by, talk to me at Toga. I'd love to hear you. Want to get your questions answered. So I will talk to you next time.